Thank you for coming. I'm Lyndon Adams. You had a good conference? Everyone's had a good one? Yeah. Last session, you've been watered, you've been fed, you've been teched up, you've been badged up, you got everything, right? T-shirts, jackets, a lot. And I have the pleasure of talking to you guys on the last session. And wow, I didn't expect to see so many. So just as an introduction about myself, I've been working with GemFire and Spring for some time now, mainly in GemFire, and over the last couple of years getting very heavily involved with Spring. But my background is from investment banking, so I spent a lot of time cutting my teeth with hard problems on a day-to-day basis with in various systems, namely from reporting to tick systems, trading systems, risk reporting, you name it. So a lot of my background or way I look at things is based upon that. So hopefully you guys will find that sort of interesting. But I'm not going to talk about that. I'm not going to talk about banking, thankfully. I'm going to be talking about real-time intelligence and how we can derive value from it and drive decisions on further parts of the systems, and what we've been doing. So I work in a team called R&D Solutions inside of Pivotal with a couple of other colleagues, and we built up recently a sort of a suite of tools and toys to work at, to try our decision-making process. So, through the session, I'm going to be talking about what does real-time really mean. I think we've all heard about what real-time means, and it means different things to different people in different contexts over time. You all agree? I can ask about half a dozen of you in here, and you're going to say, well, real-time means to me milliseconds. Where someone else will say to me from an insurance company, well, real-time means to me about 5 minutes. And someone else would be 15. Okay? Where do we see real-time cases? Well, they're all around us, aren't they, really? Everything. From banking to telcos to smart cities, medicine, and so forth. And how do we make decisions based off that information as it's flowing through as an event stream? So as we see this piece of new information, how do we work with it? So, as I said, real-time means very different things to very different people at different times of the day, different contexts. But within our industry, real-time is getting more and more focused upon because everyone wants to get more timely information. We're all sat there looking at our phones, constantly communicating to each other and expecting some form of response. But as a baseline, I like to actually say real-time generally means processing input when it's received, right? Based upon some historical information too. But there are some applications out there, and there's a great deal of applications out there that don't require this sort of timeliness of information, like your quarterly statements or your big marketing campaign analysis. That generally goes over quite a period where they do some deep analytics on it, and then they come off the back of it. And also, what is real time? When I'm here talking about real time, I'm not talking about embedded systems like your aircraft, fighter aircraft, was blasting along and looking to do some military action. I'm not talking about that. Java's not really sort of built for that, and what we're doing isn't really sort of built for that. So we'll be using different tools. So, and I should have said, if you have any questions, or please feel free to interrupt me if I've not made myself particularly clear about a certain point, or you'd like to ask, just stop me in mid-flow, okay? I work better when you guys give me something and I can work off the back of that. And then I start to relax then, because I'm shaking at the moment. Okay. So, this slide really talks about the appropriateness of the data and the concurrency of data. We have streams of data coming at us, right? And we need to do some correlation between these streams and actually derive some value off of it, right? And it's always about past, present, and the future, and how we can predict it if it's meaningful enough for me. And a typical use case there would be sort of banking, right? You know, if I'm owning IBM shares and I find that Microsoft is gone and brought the biggest cloud company out there, what am I going to do? I'm going to offload my IBM shares pretty quickly, right? But if I have inside information, I can predict what's coming out in the future, right? Or I sell them and go short and I'm good. I'll take them on the high and take them on the low. Okay? So, there's been so much hype around stream-based processing, I can hardly keep up. Who can keep up with all of the platforms out there? I mean, it's crazy, right? I'm getting old, and my brain is just constantly being saturated by this new systems, and I'm coming out here talking about another new system. Well, I'm not going to talk about that per se. I'm going to help you create your own system with the tools that we have out there. But here we can see that real-time intelligence, based upon timeliness, hits this type of graph. We have the throughput, meaning the number of events that come through. And the previous session that we had talked about millions of transactions or millions of ticks coming through at per second rates and higher than that. And that we have to deal with the peakiness of the data, and if not only sitting at the peakiness of data, but we sit beyond the peakiness of data, because we need to have that degree of flex in our systems to cope with that. So we have different types of systems that operate on different types of parts of data. So we have Kafka and RabbitMQ dealing with high throughput messaging, right? But they're not doing anything with that data yet. They're collecting it, passing it around. That's all good, right? We have ETL, which is sorts in the middle there, which says high throughput, right? And it's CPU optimized. It's not data co-located. So it's doing a different type of processing. Now, as we go along, we've got Spring XD, which is the new big toy in the box. Looks pretty cool, right? Who likes it? Who's been playing with it recently? Got to look at those hands. There's not enough hands here, right, guys? Come on. Get with the plan. All right. And so then we have Pivotal RTI, which is real-time intelligence. It's not a platform per se. It's a set of components that we built up inside of the R&D solutions team to work out what's really useful and what's not. And what we look at is we want high throughput. It's not as high as Kafka. We're fine with that. We're CPU optimized. That's cool. But we're also data optimized, which is even better. Right? And I can talk about, I'm going to go and talk about data optimization, throughput, and CPU optimization, all in one go. So has anyone dealt with distributed caching systems using functions, real-time event-based processing? Any show of hands there? Yeah, cool. So is this all new to you guys? Sort of when I talk about, if I said sharded set of Gemfire cache nodes, or a cache node, across a set of servers with multiple processes, so each server will have a set of processes that's collecting data and acting upon that data. Has anyone sort of done that sort of work? Yeah. Yeah? Yeah, you good? How are you using it? Mm-hmm. Okay. Okay, so it's quite interesting. I've worked with many clients before being dropped into my current role, where they use the distributed caching system as a golden source of data, a NoSQL database, right? It's for quick lookups. We're going to go beyond that. Let's take you to the next level, which is much more fun, and start to make you think that actually that JVM is just a JVM, and it can do other things for you. And it just happens to be that all your data is co-located inside that JVM, which is just great. And it's sharded, meaning that I have one copy of the data here, I have one copy here. So it's a bit like if we looked at the set of rows of tables here and took every table here as a cache node, and I operated on, or say these are all A's and B's and C's and D's, we would have a sharded function call. So when I ask a question, it's going out to you all. It's a scatter, right? You're with me on this? Cool. So the other thing is we see that rules and CEP engines are down here, right? So they do throughput pretty well, actually. They are sort of data optimized, but not CPU optimized. So there's a funny balance that goes on there. And then you have the traditional client server, which we all know and love and hate all at the same time, and just wish that it would go away. And, you know, I'm not going to talk about that. So just to sort of get us going, or get me going, I'm going to talk about some use cases. And, sorry.
That last slide, I don't know, maybe it's another provide. I wouldn't, based on the horizontal axis labeling, I wouldn't have thought that by placing that pivotal RTI that would have a claim of CPU optimization.
Ah.
So obviously you have two dimensions in the third, but
It should go on the Z-axis, right?
I don't know.
Yeah. This one was done for me.
There you go.
So I would have had throughput here, data optimization this way, and yeah, you know what I mean, right? I'm working in 3 dimensions at the moment, but often I'm out of those dimensions and somewhere else. But I would have had CPU optimization on a Z-axis, but it's quite difficult to show that sort of spatially. But Pivotal, the reason RTI works is that it's CPU optimized because it's actually working on data co-located inside the same JVM, and it's sat there, right? So I can actually reduce down my locks, all of those lovely things. Threads, locks, processes, the works. Is that okay? Yeah? And data optimize is cool, right? Right. Here's a subject which I know a little bit about. So real-time processing in banks is relatively obvious, right? So I'm going to flick all those up, and then I'll quickly talk. There you go. So we have Monte Carlo simulations for the sort of overnight or intraday sort of stress testing on options. That's what we usually use those for. Or we use value at risk, which is overnight, which is a much more heavier, denser type of operation. But what we want to do is actually change the price as it comes through based upon the volume of data, and also about some predictive analysis that's gone over through different cycles, or the economic cycles. So as we're going through different economic cycles, the way that we may price it may be dependent upon the cycle we're in. Okay? So you do need some form of calibration model to price this. So we use fast active data that's coming at us quite quickly, we take the historical models or calibration models, we call them, and apply the pricing model to that. Okay, so there's one example which we would use fast data, which is event data, and it's streaming at us very quickly, and we're using historical data.
But why simulation?
Why simulation?
Yeah, because simulation is simulation.
Ah, okay.
That's proactive rather than
So a simulation, if you look at black shoals and volatility surfaces and volatility smiles, based upon where you are in the marketplace, tells you about the probability of coming in or out of the money. And so you need to reprice based upon some simulation or Monte Carlo sim. So you stress.
simulation is based on the historical data?
Yeah, you do historical plus you bounce the price between a range of 15 and minus 15 and 15%, and then you take the best price out. So there's different types of simulation models that will be used, or that could be a calibration model. Okay, think of switch that simulation out to a calibration model.
You said to interrupt you.
Yeah, no, I love it. Yeah, a bit more around here as well. That's good. Am I answering? Are they okay? Yeah? The other one is customer behavior, and we've been hearing about this quite a bit, about how we're all going to be tracked, right? How our data is being collected. I often think that all these wonderful devices of Facebook, Twitter, and so forth is a way of actually perpetuating a new market and so on. But so we collect this information from the cell towers we heard before, and what are you doing? Or what are we allowed to collect? So there's that whole legal aspect which we'll leave aside. It then goes into a big data archive. This is one of the things that's been done, and where we want to actually target clients. So as you walk down the street, you might be a big Starbucks fan, right? And as you're going through and you haven't picked up your coffee in the morning, so sorry, you didn't pick up that coffee that morning, and he used to drink coffee every day, 5 days in advance, every day going to work. Then he stopped buying coffee from us, right, because he just passed here. Maybe I should send him a note to say, you're just coming up to Starbucks, have a free one on us, right? Have a free one. So this is, if you can think, it's a bit contrived, that example, but you get the idea. So you get this type of data, and it'd be for a lot of clients, right? Be a whole set of clients, and so what we get out of that is a microcube of a bit like a cube, and then you can slice and dice the clients. So what we want to get there is the patterns of client behavior or customer behavior. And then that will drive what they've previously been doing and what they're currently doing, and how you can target marketing campaigns at them at a particular time as they come across different roads or shops or so forth. Okay? The other one is sensor data, and sensor data can be your phones, just as anything else, but this just happens to be a wind farm, and bringing these up and actually understanding. There you go. Let's get this. So optimizing the usage of wind turbines. This one's talking about. This one. And what you want to try and find here is to detect errors on the turbine, and so to either shut them down ready for maintenance and bring them back up, and then apply billing, efficient billing of the turbine, reclaim your money. So the other one is smart grids and smart cities. So this is, let me just get this all going. Yep, sorry. Is that all back up? Yep. So we're all using this energy efficiency, and how do we power all of our data when we require it. So being smart about electricity, where it's coming from. So we've got it using turbines, using solar, and so forth, and actually switching between devices as and when we need it. And also being clever about it as well. You know, shutting electricity down. So when we leave a building, turn off the lights. The lights will turn off because you've left the building at a certain time of the day. It won't be there. Shut down your water, water heating. Your water heating doesn't need to be on all the time. Your heating in the house doesn't need to be on all the time. So by being clever about it, picking up information from those devices, we can then reduce the amount of energy that we're using. And so again, it's about collecting the data, reusing it, looking at historical analysis, and then applying streaming event streaming on it off the back of it. So this one talks about asset management, and this is talks about the good guys and the bad guys, and generally what's their general behavior of the good guys and bad guys, and actually how you target those guys. And get an alert based upon the fact that this particular bad guy has come into a particular area where there's hooligans and there's a protest, and there may be a situation at hand, and that you need to apply some police force there to actually control the situation. So this is being used. So we've seen this in various aspects. You know, over the past few years, we've seen a number of instances where this would have been incredibly important. Again, it's big data because we have a lot of people. We're tracking every single point of them. And you want to know where they are at a particular time based upon some event, and then apply the real-time data where they are at the particular moment. Okay? And is there a likelihood, a probability that something's going to occur? And this all gets fed through. So this particular one is now being a bit smart about your telephone. Should I ring you? Should I go to voicemail, or should I put through the call? What should I do with this call? Or should I send you an email based upon the time of day? And the timeliness of it is dependent upon the situation that you're in. So if you're traveling very fast in a car, you may not want to take a voice call. And it's recognized that from your long lats that it's not appropriate to call you, but what's better to do is to send you a voicemail on it. Switch it straight to voicemail. I know we do it already. It just says, do this, but it might come up with a semantic thing saying, I'm currently driving, I'm currently traveling, can't take your call at the moment, but can you leave me a voicemail? Be a bit more sensitive about the fact of what you're doing. Okay? So this is a tech conference. So I talked a lot about, you come here to listen to what we've been doing. So I've been doing Spring integration, right? Spring integration within inside of a Gem5 fabric. So deploying those flows, Spring integration flows, into a Gem5 fabric. That provides me with a fault tolerance, high availability, the data co-location that I would be looking for, and the event-based processing. So Gem5 gives you quite a bit of that, but what Spring integration does is it allows you to define those flows in such a way that it becomes a lot more natural to you to do so. So this slide is more about how it used to be done. You have the client server go to this way, client come in on your app and go hit the server. You have a whole load of business logic inside the single monolithic server. And then what we're going to do now is actually, and you have different apps over different servers, right? And now what we have is a pivot architecture which spins all that on its head. We say, right, okay, we'll take the apps away. We've got the servers, okay. Spread all of the data across all the servers, as we spoke about a bit earlier. Place all the applications across all the servers, which is very similar to grid-based network grid network, grid processing. Who's done grid work here? You done grid work? Anyone else done any sort of high performance compute grid work? You've done grid gain, okay. Who's done Hadoop? Hadoop, show of hands on Hadoop. Right, so you've done some form of high performance compute, right? So you split your data across. Now we're going to split the applications across. Right, so the application will be resident on every machine, a bit like Hadoop. And now, it would only jump to the node, events only jump to the nodes that are applicable to where the data is. So when I have a new call record for myself, I'll be somewhere in A, and it will hit the A machine, because data's spread out. Is there any questions on this? Because this is quite important when I start talking about Spring integration. You'll find with your applications are all going to be laid out across here. Your data is going to be spread across them all. And when I say data, so I have, let's see, if I do a credit check, might be a useful thing. So I've got my personal details, which is about my house, where I live, plus I've got all of my credit history within inside of that same node. And then I might have some of my buying, what have I currently been spending my money on over the last year or so. And then, so that gives me some sort of context. So I've got sets of data. So I've got my name and address, where I live. That's pretty important because if the house has been blacklisted, yeah? Because you suddenly go, if you want any further credit, you're out. They just say, well, you got a bad house, that's it, you're all bad, which isn't nice. I haven't had that done to me yet. And then we have our credit history, what we've been doing over the past year, and then we've got some sort of buying history. What have we been buying? Have we really got enough money for this £1 million credit line we want to run up? Probably not. Not for me. So that's all co-located in here, all in one JVM. Okay, and it's based upon my ID, and you link it via the ID. Okay? Yeah.
So if it's located in one JVM and one of the JVMs crashes,
Mm-hmm.
what happens then? Is there any clustering or replication of that JVM? Like instead of having one, we have multiple copies of the same one.
Yeah.
Can you maybe just dive one level deeper on all this stuff? Because it's A through D through J, those are ID spaces, I assume, but
Yeah.
the replication and sharding and stuff is a little bit unclear.
Yeah, okay. So I've got, let's go over sharding and redundancy. Is that the question? Is everyone good with that? Yeah? Right. So I go over about the sharding and what that really sort of means. So redundancy is, yes, you would have redundant data. So when I do a put into the system, it will say, I need to go to bucket A, B, and C, or bucket A. And that bucket A will be resident on another node. So it will be on one over there, and it'll be on one over here. So if one of the machines go down, you have another piece of data that comes up. So it's already there. And it's all event. So when that occurs, this has a feedback loop back into the Spring integration thing. And it will kick off the flow for that piece of data if it's hooked up. Now your question was about sharding and...
I'm trying to understand the diagram.
Oh, the diagram, okay. Right, so customers for the surname, customer surname, what we're going to do is we're going to lay the data out in such a way that all the data goes across here. So all customer surnames between A and D sit on server 1, server 2, and so forth up to Z. Okay, is that? The applications, so remember I said it's just a JVM. So we can have a number of flows within inside of that JVM that acts upon the data that's resident inside of it. Okay, they're all sat there too. Is that a bit clearer?
Yeah, what are you using for a data store in this? I mean, are you using Cassandra, or are you just...
So the data store the data store I'm using is Gemfire. Okay, so that's pretty much all I know very well is Gemfire. Okay.
What makes it necessary to jump a node?
if, yeah, okay, a join, a piece of data that, let's see, let's,
So all data isn't replicated on each.
no, that's right. Not all data is replicated. So we have, so for very big pieces of data, for large amounts of data, right, imagine trades, right? So say you get 10 million trades a day. I can't put 10 million trades here and on every single one of them. So it makes much more sense to divide out those trades across all of the nodes and have some level of redundancy in the event of one of those nodes failing.
So it's on at least two.
It's on at least 2 if you choose to have it. But again, that's dependent upon your use case. You may feel that actually this data is just throwaway, so I'm fine with 0 redundancy and just bring it back up. There are other cases where you would have supporting information, reference data, that's less volatile, and it will go on every single node. And for there, let's take an example, go back to credit, it would be credit ratings. The semantics around that, the rules of that. How do you operate on it? So if I had a credit rating here, and I've got this new request coming in saying, I want to find out, is he worthy of this new credit line? And it has a set of rules, or defined rules in here, and you can apply that. Does that make sense?
Yeah, but I'm not sure that's still, I'm not sure that answers the question, right? Jumping across nodes. You're
Jumping across nodes.
join.
Right, so jumping across nodes, sorry, I missed that, sorry, thank you. Jumping across nodes, brilliant. Jumping across nodes is because I may need some further information for my function, and it may not be resident inside my JVM, and that's when you would jump across a node.
Yeah, we said similar to Hadoop. Like Hadoop, normally you have the data replicated based on replication factor, right? And you would have a name node which will tell you where the data resides.
That's right,
So
yep.
here, how do you keep track of data? Is the way I want.
We have a locator process that does the same sort of thing.
Is that the distributed cache you're saying?
Yeah, so we have another process sat here, which when these nodes come up, they say, right, we're going to take these buckets, and the locator will keep track of where those buckets are. So when the client comes in and says, can you give me the meta information of the cluster? And it returns back the meta information of where that data resides, or where those buckets reside. Is that okay? Yeah.
Is that the different processor or what exactly that piece is?
What, is it a different process?
Yeah. So that your indexer that keeps the track of the where partition data is residing, is it on the outside of these boxes or they are already in all of the indexes are already with everyone?
Oh, okay. So it's not an indexer, it's a management node. That's sort of similar to a name node. And it would say it's preferred to be not on one of those boxes, because then you can do network partitioning, work out if a network's gone. But that will sit out, that creates the cluster per se. And that will keep track of all the meta information of all the members within inside of the cluster. And they communicate back to the locator, and then the client gets feeds from the locator as it comes on. Okay?
You scale up that locator service.
Yeah, you tend to have 2, at least 2. It's a very small process, and you would have it definitely on 2 different boxes, because you want to detect network partitioning. So, and all it really does is just keeps the information for you. And you can have any number of that you want, but it's generally 2. Okay. So what we've done, we took Spring, which is the Spring integration, and it's not just Spring integration, but everything of the ecosystem. Take the whole ecosystem, bring it together and put it into Gemfire. We now have a distributed set of integration flows. We then pull some widgets together that we built. They're geospatial and sets. And so we have distributed sets and distributed geospatial based on events. And then we just apply it all within inside of the Pivotal ecosystem. Yes. They can run in the context of Gemfire, or you can take them out of there. It's how you hook the data up. What does it exactly look like? So it's just Spring integration. So I purposely didn't put any code in here on purpose, because I think you've all seen so much code. My eyes just flick off when I see more code. So I put pretty pictures up. But effectively, it's a Spring integration XML document. And you define off your flow, and whether it's routing, filtering, transformation, and so forth. And as the data flows in, you can actually say it hits a set or a geospatial service. Out of there, it will come out a yes, you're a member of the set, or yes, you're in this polygon. Yes. So, okay. So you get this application context, right? So you have that application context. What happens is data. So let's talk about how you kick this whole flow off, because that's quite interesting. So I want you all to walk away and go, right, I'm going to have a go at this, which is you have your Genfire cluster, and they have things called regions, and that's where your data goes into. So my client will do a put onto a region, a key value pair onto a region, and off the back of that, you're going to have set up a Spring integration flow. You would have an outbound adapter, a Genfire outbound adapter, that's linked to the region and on the create event. So you have it'll be an empty region that you use, so it's just like a message region. It hits that, and then you just use your channels, your filters, your transformers, and so forth from there on in. And then once you've finished, you put it onto an inbound adapter onto a region. That all make sense? And also the nice thing is that because you're inside of the JVM, you can use the Spring expression language to look up data on regions inside of that JVM. So as you're going through those steps, you can start looking at data as you come through it, right? So if I...
The advantage is I'm executing my program basically data in memory.
Yes.
The in-memory speed that processing. I'm not calling out client server to some data
Yep.
source in order to process that data
Yep.
in a different JVM. I get to do everything locally per partition.
That's right. So the way I used to code stuff up, and I've done countless sorts of POCs, is I would have to write up, I would hard code a lot of this logic. So there'd be no Spring integration. I use Spring Genfire, but there'd be no Spring integration. Now, after doing this, working with this, it makes it so much easier. So much more easier. Now it's not... Yeah, it will slow down performance because you've got the expression language there. There will be a performance impact. So it depends upon the timeliness of what real time means to you. If you, so remember, when you talk about performance, it's all relative to the application you're building. Okay? And you're only as fast as your slowest component within inside the system. So remember that too. So you might be trying to optimize the wrong piece, but forget that. It's not the actual integration piece. It might be a call out to the database to get the data in. So for example, Genfire has the ability to do, on a cache miss, it would go out and get some data either from some resource out there. But you're absolutely right. So now what you have is that you're operating on data within inside the JVM. Okay? And also, you're sharding the processing. So you're scaling your processing, real-time event stream processing, right, with data co-located within inside of that. Yeah? And because we're in Spring integration, we can use everything. You know, you have all of the adapters. You fire off events going up to there to that adapter, or pick up some data from somewhere else if you're missing something. So you have all of this as well. Whereas if I didn't use Spring integration inside the Gemfire framework, I'd have to go out, build all these, bring these libraries in and start hard coding them. The other thing is that we C24 are pushing data into us on byte buffers, and they relate directly down to the Gemfire's PDX system. So we can see that, you know, as we got flows coming through, that we can do some merging, provide some business event, do some sliding windows. We can evict the data out. We can control what data is actually live in our system, and we can actually operate upon it with all these nice things here. So we've got this widget here coming through saying validate it, enrich it, filter it, right, and then perform some function upon it, meaning your call record. Let's take your call record. I'm going to give you a demo in a minute of some of the platform that we put together, which is contracts, your personal contract with a telco provider, and call records, your current calls. So let's say my contract's coming up for renewal, or I might be out of it. I may be out of my contract and I can leave any time. And I'm starting to get a lot of drop calls, right, in my local area, in my house, in fact. So I might want to actually track, and I might actually have a situation in a particular area. So I might want to do the intersection of contracts IDs and drop calls and get a live streaming intersect on that. Yeah? And then I may want to know from a telco perspective how well a cell tower is performing, or how many drop calls a cell tower is having. And again, that is, I've got these call records coming in, they've got long lats, and they need to be linked to a cell tower. And I know you would get a cell tower ID inside of that and it'll link it, but we can show you how we use long lats inside a polygon, saying, yes, we are inside this polygon, it's in this general area. Scotland's in the UK is having lots and lots of drop calls, let's say, or north of England is seeing a high amount of drop calls. We need to, and that's going over time. And so we're taking historical information and we're looking at real-time information and saying, well, actually, we've got a problem here. We need to invest more money in here to fix this up. Otherwise, we're going to lose our customer base in that particular area of the country. So we can use sets, and we can use geospatial. And then we've got accumulators, which says, you know, how many drop calls are being across the area. We can perform analytics off the back of that too, because it's all in memory, and we can distribute the analytics over the whole cluster. And you have threshold functions to say when an accumulator goes so far off a new event to kick off this new stream. So you might have an integration flow that deals with high drop call event stream. So this sort of is more around sort of the R and Madlib and so forth, where you can take all this ingestion out, and then we want to collate some data in here, perform some geospatial models, and then push that back up into here, and then compare the piece of data that we got at the moment to the actual model, and then fire off a new event, say, actually, something's going on here. And here we may look at marketing. This person goes here, 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 all around this sort of area, and he constantly does this. And now he's out of the norm. So you got that model of that particular person, and now suddenly he's spending a lot of time in this particular area, and he's a bad person, right? So that's quite important, right? So that hotbed of activity that was there is now being moved across to here. And the only way that we can find that out is by tracking that information, creating the calibration models using big data analytics. So we do all of that crunching. and then taking the streams and saying, right, let's mash this together and seeing how far away is this person. So the distance from his general area or general polygon that he operates in. Any questions? So, and this sort of talks about the geospatial stuff, which is, anyone know what the term debouncing means? No? It's quite a strange one. You know, we have these sorts of mini cells around the building. So to work out where you are in the building, there's one over, you get bounced around. Your signal could go to there, then it could go to here, flip between that. So you don't really know where you are relative to the actual positioning of you, which is, it might be a meter. It might be really important, right? So that's you need to debounce that, or basically stop the bouncing of your signal going from flipping to here, so it's pinging backwards and forwards. So that's what debouncing is. So we want to get rid of that. Also, we talked about leaving zones. So it's just going in and out of a zone. We want to do the distance to the point of interest. And there was a question on the last meeting about could you work out the average speed of a person going up and down, going up a motorway? Well, you can actually. It's just a distance function between two long lats. And you can get it from the phone, telling you how fast you're going, but actually, if you're going over a set of points, what's the average, have you slowed down, you can get that particular information. You've got friends in the area too. So, I'm going to bring this all up in one go. The other thing is we've been looking at is composition of those flows. So each one of those flows has a particular function. And what I want to do is actually say, I want those drop calls. So you might have one flow that's just dealing with drop calls, and that's all it does. And I want to read from that flow and drive another flow off the back of it. Okay? And a completely independent flow too. So these can be seen as an application. So we can then have cells that saying, well, look at expiring contracts. Because the sales team would look at expiring contracts, may have a whole process about going through, about saying, trying to get you back in, get you signed up for another 12 months or so. And we can have marketing, let's start again. We have drop calls, we have expiring contracts, and because this has happened quite a bit and you were a really good user, the likelihood of you moving away because you use your phone a great deal was quite high. So on our network, therefore, issue a rebate for you straight away, and then work out what the problem's actually happening in the current area that you're dealing with. So there's your biggest set theory there, which is your intersect. And then we've got your geospatial saying, well, where is the general problem for this actually happening? And have we had historical issues with this? Was this something new? So being a bit more lively about what's going on. So this is what, real-time intelligence is all about that. Does that slide make sense? So I'm going to take data out of these flows and mash them together. And so you would have an independent flow. And so one of the things I was doing was I wanted to show that actually you could just have these XML files. So you have, for every flow, you have your own XML file. And then you have an endpoint on that, which will be a shared container of data, which you can read from. You can't write back. You could write back, but you wouldn't write back on this particular instance. And you take those pieces of data from those different flows and bring them together. So you can have independent developers looking at those flows and optimizing those flows independently. So you start thinking of those as applications. You could think of those as applications, but I prefer to think of them as flows. And you can deploy those flows into the Gemfire fabric or any other fabric. Sorry, yes?
So you're showing on the far, kind of the middle, and you're showing this hierarchy of boxes or applications. You're showing me the Spring XD applications. So is that whole path is kind of part of the Spring XD kind of structure, or is there
So this isn't particularly Spring XD per se. This is something we built up from scratch up because we were running at a different speed to what XD was running at. So we're going to bring that back into the fold. But ultimately, you have, this is basically a URL link. And each application will have a URL link. And you publish that out and say, I have publishable data. The other way of thinking about this is in a large enterprise organization, big organization, different teams work on different pieces of data, right? They have they take an input and they have an output from it. They create some value for it. Some of it's end of day, some of it intraday. And think of those parts of this in your organization as generating different pieces of information off the back of it. So, you know, the marketing might be really concerned about customer retention here. And so they're going to take out live data feeds from both drop calls and take a static feed from your sales department about expiring contracts and bring those pieces of data together. And then you might sort of have something else in there, which is the likelihood of movement. Does that answer your question? So you have you think of it as different applications. You would like to see a demo? Do you know what? Sorry? Yeah? Yes.
On the previous slide, those URIs were, what do they think of those as concept topics or just
Yes.
link?
Yes, you can think of it as that way, yes. Yeah, in a normal ESB, they would just be topics, wouldn't they? You know, nice common denominated topics. The way we've done it is just said, well, we have a hierarchy of this. It says my company, it's my company. And if I want to take out data from another company, so I have data feeds from another company, you might have a different level of hierarchies on there. Possibly. That's
I don't want to imbue too much into that.
yeah.
Because it's normally then you start thinking quality of service, stuff like that.
Yeah.
Right? And
Oh, yes.
consistent usually in RGS, right?
Yeah. Yeah, there's a whole load of complication around. Remember, this is our.
It could just as well be just a name of a channel or a gateway.
Yeah, absolutely. So a lot of this is R&D work. So we're proving stuff out as it comes through, and does it make sense or not? This was very powerful. This was great. This sort of bit, this did work. This worked nicely. And the shared containers could work too. So XD, I'm hoping that we can get the shared container data out to XD so that Gemfire could be creating this data and then just says, I'm going to publish it to an XD stream and for you to pick it up, and then you can just start working with it. So you've heard me talk a bit, but you want to probably see some tech to see how does this all stuff work. So I'm sorry about the color of my screens, but that's how I develop. So first thing I'm going to do is, no. First I'm going to do is I'm going to start up the cluster. And I've tested it before coming here. It worked. Yeah. Right, so first thing what I'm going to do is fire up a cluster where it's going to have a locator and it's going to have 2 cache nodes. So I've got 3 JVMs up and running. So first, you see those dots there? That's going to start up the locator. Now we're going to start firing up the JVMs, cache JVMs. Yeah, so that's good. That's running. So let's see if make sure it's actually good up and running. So I'm going to write something called gfish, and I'm going to go into a nice graphical screen in a moment. So I'm going to connect to it. So I'm going to connect -- locator. It's on my local host. I'm running on port 41111. So there we go. We're there. We're connected. Now I want to make sure that my members are there. So I'm going to list my members. There they are. So you can see I've got server 1 and server 2 and a locator. Have I got any regions in there? So do that. Yep, these are my deployment-based regions. That's all good. So at the moment, I don't have any applications in there. It's just a naked Gemfire. Well, it's not naked. We've got some other code in there that's going to accept a deployment. but there's no application code in there. So I've got this thing called deploy. I'm going to deploy my app. And once that's done, it's now deploying that to the cluster. And if I look on here now, I've got some regions. So for people who can't see that very well, I have calls, contracts, drop calls, and geozone drop calls and review clients. Okay? Yeah. I just deployed code to them. So let's have a look at a UI. There you go. Did you see that? Did you? Oh, hang on a minute. That's localhost. Was it? Was there? Ah. Hang on. Let's do this. Hang on. No, that's all good. That's all good there. So I'm going to start it up from here. Start pulse. So, okay. So admin. Okay, so now we've got a cluster up and running. So once this actually refreshes, there we go. Got 3 members. Here we go. 3 members, 2 servers, and 1 locator. Okay. We have. Let's look at the data view. So make sure we're all looking good. So we have. Is that a bit better for you? Is that a bit more viewable than those horrible little things? So you see all the regions at the back there. That's good. So now what I'm going to do is I'm going to fire up a Tomcat server. Okay. Now my Tomcat server is up and running. So let's get this up. So this is the UI. Come on. Please come up. Right, okay. How does that look? Oh, I need to go a bit small on that, do I? Can I get that? No. Sorry? Command minus minus. How about that? Is that a bit better? Oh, there you go. That's better. Okay, so what we have here, map, we have our drop calls by region. So I'm going to stream some calls in. First of all, I'm going to stream some contracts in, so they're going to be expired contracts. And I'll randomize all of this. This is all just hokey pokey data. I have, this is going to count out the number of dropped calls we've had in a particular region. So this is geospatial stuff. And then we have contracts which we need to be alerted upon, which is on my left side. And then this is just going to show where the calls are being dropped, the map is. So the next stage is I've got a client. So, right, let's feed our contracts in. Let's go back into here, and we'll see over there at the very top, we're starting to take contracts in. We've got contracts in there. Okay, we slowed down this demo because we gave it to some other people, and we just wanted to show as data flows in, you can start seeing it all flick up, and it looks a lot easier. Otherwise, it's just like that, and you don't see anything. You go, well, you could have just said 5 there. When we said no, we'll slow it down so you can actually see it. So that's good. So next stage is I'm going to put some randomized calls in. They're just random calls about where they go. So here we go. Go across to here. Right. This is where I hold on to this for dear life and say, please work. I dare not move anything. Come on. That should be working. That's bizarre. Oh, I didn't say C for calls. Sorry. I am. So now what that's going in, hopefully, is now you can start seeing it updating. So now, all those calls, all that logic of working where geospatial, it's saying, I've dropped a whole set of calls in this area. I've got those over there on the grid is what contracts I need to be aware of that I'm having these drop calls upon. And then we just sort of the geospatial. And you can see London at the moment has, or south of London, has got quite a few calls in there. So you can see I've slowed it down. It would be pointless if I just did it all in one go. It just flash up in a zip. And it just, yeah, I believe you, Lyndon. Just like your slides there. All look nice and graphic-y right now. There you go. That's that. So the next thing is, let's see. So let's see if I can find two. So I've got one here. It has two. So this particular person had two drop calls. There's no intelligence in the UI. This is just taking data from Tomcat through WebSockets. I'm going to talk about, has anyone got any questions on that? Because I'm going to talk about the technology that we used to get to that point and the sort of general architecture. Yeah? Is that all good? Cool. Right. And so we're using Spring integration for the use cases. So we've got set theory for streaming integration sets using geospatial service that we built. We've got open layers, which is the map. High charts is for the bar chart, and our JQ widgets components for this bit here. And that's for the UI. To push that data to the UI, I'm using Tomcat and embedded Gemfire client. So I'll talk about that now, and then we're using WebSockets to push it out. And obviously we've got a Gemfire cluster behind that. So you can embed a Gemfire embedded client process that receives events from the cluster and then pushes out that event onto the WebSocket. Okay? And then the GUI just picks all that up and starts working through it. Yes, Tomcat is a Gemfire client. So we use a radius for these, so for the polygons, so we divide the UK up into a set of polygons, and that's quite nice. So we then use Google Earth to trace all the polygons, and we get out a KML file, and then we bring that KML file and we specify our sets of polygons, and then we can say from a long lat, we can say, are you in this polygon or not? And that's how we get that piece of information. And the color coding is purely from open layers and how that's provided. And that takes a streaming of drop calls. So we already worked out through SQL, through the expression language, say, is this call a drop call, yes or no? And if it's a yes, it then gets pushed into the drop calls region, and off the back of that, you then have another listener from your geospatial stuff to say, right, I've got that piece of event, I can fire off this whole flow here to see if it's, and create off that. Okay, contract alert. Yep.
Presumably you could quasi change the rules coming in, right? For example, if you wanted to want, I don't know, people who are searching for Starbucks, would that work with the existing
Would it work with the existing? The general concepts would work. The general concepts would work, but it requires a bit more around that. No, we're using expression language. So yes, I can plug in a new expression. It can come in through that piece of data. If I've decorated that object with enough attributes in there, where am I? Is he a coffee drinker and so forth? I can certainly do that. Today, we haven't done that so far. So contract alerts, that's purely sets. Streaming intersects, which is quite neat. And here's a bit of SQL we use. Is it a drop call? Is it dropped? Yes, it is. Put the contract ID into the intersect, and then when that gets fired, it then pushes it out onto the review clients region. Okay, so that's how.
Sets?
Yeah. So we use sets in this particular instance. So we got set A, which is all drop calls. Set B, which is contracts up for renewal, and then the intersect. We're going to say, right, what is the intersect of that? Which is good. Okay. Then, so here we're just taking a list of this, so we're creating aggregate counter for each region. So this is what this is really sort of showing. So we've got a set of calls in a particular region, we take a list of them, and we're just doing an aggregate number of drop calls within inside of a geographic region. So then you can know, then you get a sense of where we're all dropping off. So the next slide is pretty much describes it all. There you go. Is that a bit better? Yeah, that's okay. So on my right-hand side, your left, we have the client pushing in, and the client is just an ingester process that we built up. Very simple, just create a whole load of data. And all it's going to do is do a put all into the Gemfire platform. They hit Gemfire partition regions. So you know when I talked about the sharding, we call them partition regions. So there's two different types of regions, partition region and a replicate region. They go into those maps. So Gemfire is a map, not a set. We then push this data into the set widget that we have, the flows that we created off here. This will either fire an event into the review clients. It will then pass itself up into the Tomcat web container, because the Tomcat web container, we've got the Gemfire client in here, because that's a client too. Exactly the same on the other side over there. And that will do a register interest on all data for review clients and drop calls and GeoZone drop calls on those regions, on those data regions. Yep. The other thing is that now I've got drop calls, already got the drop calls. Where is it? Where is this drop call being placed? So I now want to create off my aggregate counters, and then let's do something interesting about that, and that's what we go through on the Geo widget here. And we start pushing that through. Does that all make sense? That's all pretty clear, right? That you want to go from left to right, and you can see it ending up in the web, and then it goes out on a WebSocket to the web browser. Now, so finishing off now, I purposely didn't want to do code, and hopefully, I know everyone sort of does code here. I sort of fancy doing something different, and I hope that's okay. But, and if you do want to see code, you can come up and we'll talk about it, and I'll show you how it's done, and or you just email me and do it that way. I'm going to bring everything to a close now, which is, some streaming is highly intensive on CPU. It can be. And so you need to be sensitive about that fact. And you would use techniques to actually reduce that CPU intensity, such as grouping batches of small micro batches of data to operate within. There's no point, so streaming, if I go tick, 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 right? A bit like a machine gun. Okay, shoot a machine gun at something, it's just going to fall apart, right? What I really want to do is just do it one at a time. But that one at a time, I'm going to give you a small batch of work on. It hits that processing unit, and then we'll start executing within that. So it becomes a lot more sympathetic to the machinery that you're using. So we're not going to be doing context switching and doing that rat-a-tat-tat on the registers. It's all going to be sat there. So you need to be sensitive about that fact when you start building up any of this stream-based processing and your intelligence that you want to make it off. Please don't go down the line of dealing with one event at a time. That really doesn't work that well. May also want to consider what we're thinking about now is resilient data structures. So depending upon your environment that you're in, and depending upon what real time means to you, and the value of your data, and what you want to, what's your end result of it, will depend upon, one, the size of the batch, and how you, and also about the replayability of that data. So we start thinking about resilient data structures. There's a paper out by Google that is a beautiful paper out by Google that talks about resilient data structures. I've been talking about it for a while. I've used it a while, and that's interesting. The other thing to do about stream processing is, I think XD will probably talk on this too at some point, is talk about stage event-driven architectures. So there we start thinking about, if I'm doing a matching platform, right, trade matching platform, I have a whole load of trades that come at me. I want to get a nice spread or even distribution of compute across the whole platform, right? And I want to fully utilize those assets across there because they're very expensive, right? And the next thing is once I've done some sort of matching criteria, I might want to do some further processing on it, meaning some portfolio risk analytics, some sort of market value, portfolio market valuation, or something else off the back of that. And I may want to do some alerting based upon the levels that that trade's occurring, or that trading's occurring for that particular account. And I want to fire off an event off the back of it. So there's sets of functions off the back of it. And I can start to take up all of those trades that spread right across the whole cluster and narrow it down to the portfolios that I want to provide alerting off the back of it. So I reduce the number of compute. Is everyone with me? Yeah? So what I'm doing is making a pyramid of compute. So my first level looks like a neural net, funny enough, and it goes, first of all, let's match off what I've got here, put it in the right bucket, and make sure that's nice and compute because there's lots of these trades coming at me. My next level is right, now I need to perform some aggregation on this, or I need to perform some aggregation, which is just the portfolio valuation. And then the next stage on top of that is, right, I've done that. I now need to perform some level checking or limit checking saying, have I breached the limits that I'm allowed to actually trade on? Right, and that will cause an alert that will then be that feedback loop back out to some compliance officer or someone else. But what we've done here is that we become very sensitive about the way compute is executed. Like when you do Hadoop, right, you fire out your Hadoop job and it goes out right across the whole cluster and everything's running. Well, I've done the same thing here, and then the next stage on, I'm reducing it. So that's something else I wanted to leave you with about thinking about stage event architectures and how we can use those. But ultimately, I mean, what we've done so far is we've shown we can take a Spring ecosystem and put it all into Gemfire JVM, bring it all together and utilize Gemfire's capability being fault tolerant, highly available, the eventing structures in there, and all of the other other nice functions within that, and provided out a decent solution with a minimal effort on a coding level. The cool thing is, if I went to do a POC tomorrow or whenever, I would probably look at Spring integration first off to say, how little coding can I get away with, and how timely is your system? Yeah.
So maybe I'm being misled by a reading too much. So when you say cluster aware, right? Does that suggest to me that those widgets have domain knowledge about some sort of domain knowledge about would, maybe the correct term would be, cluster embedded.
Yeah. Just reading that there as sort of, it does need to be cluster embedded. Cluster aware widgets is sort of tells you that, well, I know about my environment I'm in. A good point. Yeah, they're not cluster aware. They're just a widget, which I'm expecting to take that widget out and place it into anywhere else. It doesn't have to be in Gemfire. It should be anywhere else that we're actually using. Right, so, wow, I spoke longer than what I thought I was going to speak. I must have been rambling. On that note, I'm open for questions. You've been wonderful that you all haven't got up and left after the first 10 minutes. So I'm here for you now to bombard me with a whole set of questions on things which I didn't really cover, and it's over to you guys.
There was a question about Cassandra earlier when you were looking at one of your slides. Where you
Yes.
that, I thought the same thing at the same time. That's kind of how Cassandra automatic works internally anyway.
Yes.
In terms of sharding, I think that's what I had a question. I go, wait, that's not in the IO portfolio.
No. I mean,
Not saying one thing or another.
no.
I discarded it because of that.
Yeah.
But that was as soon as I saw that, I thought exactly the same thing, right?
So can you help us understand where this technology lives in the world of real time and big data?
Where
You showed that one sort of graph at the beginning, but I'm just, you started out by saying there's so many different things, it's hard to keep up, and this, to me, is one of those things where it's like, okay, it seems like it did some cool stuff, but I don't know why I would choose this technology over another.
Yeah, okay. I'm sort of presenting this because you must enjoy doing Spring, right? I guess you all do, right? If you don't, put your hand up. I mean, that's all cool, right? I didn't once upon a time. Now I'm fine with it. I'm just dandy. So what we're giving you here is the ability to do something different, or to use your current skill set that you have built up over your course of time, and apply it to something new. And you don't have to say it's in Gemfire. You could use it in Cassandra or somewhere else. That's your choice. But where does it live? It lives in your tool set. So when you see your next problem that you're coming along and saying, well, is this stream-based processing? And do I have a big data problem, meaning all my data doesn't sit on one machine, I've got a whole set of machines, and I can independently execute processes in parallel, then this comes up. This will help you a lot. Does that answer the question? If you have a problem, right, billing, for example, we used to do things in batch, right, overnight, right? Who used to get called at 5 o'clock in the morning saying your batch is broken? Everyone had that? Yeah, there you go. How horrible is that? It's horrible, right? Yeah. I hated that. Made you a good programmer, right? Do you really need batches today? Do you? Are you sure? Just turn it on its head, right? Because information's coming at you constantly. You may be able to change your detailed data. You do need for overnight P&Ls because you may not get all the trades in and so forth. So there are some things, right? But you can still do that on an event-driven process. So, I'll give you an example of banks, right? Prime brokerage. As a hedge fund, you trade with a set of prime brokers, right? And so, but you send trades to different brokers at different times. So there's no reason why you can't run value at risk as soon as you receive that whole trade set from them. No reason at all. You may not want to do it intraday, but you could do it at some scheduled period of time where you can execute value at risk. You don't have to wait overnight. market value. You can do it immediately. I receive the trade file from the hedge fund. I can do a market value immediately. So you don't have to do these batches. It's sort of getting away from batches. Prefer yourself to say, does this have to be a batch? Now, I've said real-time intelligence. I'm moving away from that, saying, well, use the same technique, which is, I've got my data in my data store. It's pumping in. Now affect something off the back of it. It's event-driven architectures. And once you get into event-driven architectures, life becomes easy. You don't get that 5 o'clock in the morning call. Yeah. Yeah, so, okay, so you've got a client, your client application that's going to publish data. Okay, so it's going to publish data and it's going to hit a Gemfire data storage region. Okay, so it hits that region. And then what you do in your flows, because your flows and context is all brought up inside the same JVM, you're going to attach an outbound adapter to that region. And you're going to say, which is effectively what we call in Gemfire cache listener, but Spring, it's called a cache listener. So after the event has occurred, meaning it's in there, we're all good, fire off another event and chain off those events. And what that will do is you can then fire off you've got that piece of data, it hits there, put it onto a message channel, and then do your routing, filtering, transforming, and then carry on through there. And it might be, right, I've got this new call event from you, okay, and I want to know where you are. So I say, right, okay, what region is he in? So I just put it into the geospatial, it goes through a message channel and hits the service activator for the geospatial stuff, and it out pops in a where you are, a polygon of where you are. Okay. No. So what happens is that the client will publish a record directly to a partition region JVM. So partition region, I don't expect to sort of talk so much about Gemfire, so you're all getting free Gemfire consultancy here now, right? So who wants to know what a partition region is and what really happens underneath the hood? Show of hands. Otherwise, I'll stop talking. I'll go home. And you say, yay. Right, so partition region. So partition region is sits on every single cache node. So my region, let's call it calls. Right, so I want to have a calls data store. And underneath there's concepts of a bucket. And you have a set of buckets. Each JVM will be allocated a set of buckets, and they'll be the primary buckets. So if you have redundancy set to 0. So you have a set of primary buckets going across every single JVM. So this is going to talk about HA and failure and restarting flows as well off the back of this. So the other thing is if you set it to 1, it will then say, right, I'm going to move those, spread those primary buckets across a set of other nodes. If you set redundancy to 1, yeah. So it will set another a redundant set of buckets. Now the buckets is simple. How do I say, where am I going to get allocated to this call record? So I'm going to use as my key, because remember Gemfire is a key value, right? For key, you're going to use, you have to do hash code on there. You say, and equals, you would say what your key is, you're going to key it on. Right, so for example, in calls, you might want to say, I want all of my calls that I'm dropping need to go to that machine, right? And what we do is take hash code mod, the number of buckets, and that bucket ID will go to that machine. And we'll do a put into that machine, and when that will know to replicate that data off to the redundant bucket. Is that clear? Yeah, and then that's how you get your event flows. So here's a cool bit, right? This is the more advanced aspect of it. How do I do HA flows? Right. And you know when I talked about resilient data structures and all that sort of stuff, you must have been looking at how do you do all of that stuff. So you have a micro batch, you put it here, it's a micro batch of data, it goes to that place, which is a holding place. It might not be calls, it might just be micro batches. And I give it an ID, which is good. And I then operate on that. And what happens mid-flow? My JVM craps out. If I have redundancy set to 0, I've lost that data, right? It's gone. Set it to 1, however, or 2, but generally 1, that data would have gone over to another bucket, onto another machine, because, and here's the thing, is when I do a put, I won't get acknowledgement back from my other machine until it's all over there, so it's consistent. It is always consistent. So it will hit that other machine, so I die. Here we go, yay. My other machine says, it has a callback, says, I've just received a bucket, my bucket, the redundant bucket has just become primary on me. It becomes alive, and you have a little bit of callback code, and you write a bit of callback code to say, if this bucket has become alive, put it back into the region, and everything starts off again in that flow for that particular event. Does that sound good? It's really very easy.
Is it something where to, like, I mean, it seems like project Waldemar is also doing the same.
Sorry,
Project Waldemar.
Database.
Yeah.
Voldemar database is
Voldemar, oh, okay. They're one of our competitors, right? I can't comment on a competitor's product. He's Voldemort. I don't know, actually. I don't. I look at some things, but haven't seen that one. I haven't looked at that one. I'm just being too busy being busy. Yes, a question right at the back. Yes. Can I give you any more information on that? No. Sorry, I can't. I would love to be able to talk a bit more about that, but unfortunately, I haven't been close to that at all. I'd love to understand that a lot more. Being a smart city, smart grid, sounds pretty cool, right? But just think about your house. Think about, I don't know, I'm quite tight with my money, right? So I don't like to lose my money. So I turn all my heating off and I schedule it, and thinking this is so silly. So silly. Why don't I just hook it into my calendar to say, I'm on holiday, don't turn the heating on, right? Because I don't need it, right? And I'm on holiday, don't put the hot water on, right? Which is great. Why can't I do that? So that's being smart about your environment, about your house, and about yourself. So that's information about me going into the systems and getting them being clever, right? And here's some historical things. So big data, right? So forget about the big data concept, but let's think about data prediction over time. It says, well, I come back home over time, one every day, at 5 o'clock. So if it's learned my behavior at 5 o'clock, it knows to turn the heating on at maybe 4:30, because I'm tight, right? Because I keep my jacket on for at least half an hour while I'm inside. And I put the water on at least, because I might have a shower before not before taking off my jacket. I have to take my jacket off, right, to get warm. But you get the gist, right? So you could do that, and there's products coming out thinking about being smart metering and smart homes and so forth. There's no reason why you can't do that. So expand that to a bigger scale, right across a city, And then you can start seeing the energy efficiencies about what you can do. And by reducing the amount of coal we actually burn to the amount of solar heat that we get. Yeah? So I made all of that up, by the way. But did it sound all right? Yeah. Any other questions? Because you're all sat here not getting up now. No, I've got no one.
How about the scalability? If I want to add a new node to the cluster, talking about the Gemfly, I want to add a new node to the cluster, how the data will be rebalanced? Who is responsible?
Okay, great question. That's a really good question. So I'll repeat that. I've got a cluster, more data's coming, and you say, right, I need an extra node, right? And so you just add another node. You just bring another node online, and you hit the rebalance flag. There's something called rebalance in Gemfly, or it does it automatically, and then it would just take those buckets and move it across there. And that's how it does it. So it just starts to reallocate buckets to another machine. It will still service you. It's not until that's all up and live and running, it then sort of shut down those other pieces of data. Okay? So it's if you look in partition region helper, there's a rebalance operation. Or if you do it on a command line, you can say minus rebalance. And when you bring up something, you don't do that when you bring a cluster first up. You only do it when you bring new members in after the cluster's established. Otherwise, there's a rebalance, rebalance, rebalance. You don't need a rebalance. Stop rebalancing. Just do it once. One more question.
So let's say you put the redundancy as like 2.
Yep.
And you have now 3 nodes. So when is it a client-side routing? Is it like pushes the data to all 3 nodes, or is it master communicates to the other 2 redundancies?
No, it's from the client. From the client, yeah, pushes it all out. Yep. Right, so I've managed to speak for an hour and a half, which is about an hour longer than what I thought I was going to speak. Honestly, coming in here, I was sort of going, oh my God. And if there's no further questions, I'm sure you guys are looking forward to your weekend, long weekend and so forth. But, so thank you very much for attending. If you do want any further information, I can be found there. And also, you can videos. That should have been. You can find me on the Spring website as well. If you forget who I am, and you want some information, I'd be happy to assist if anyone wants to have a chat offline now. Thank you.